So, welcome to the video lecture series on theory of computation. In today's video lecture, we will be learning about the way of converting NFA with epsilon to NFA. Now, when you see this diagram is having a state called as spanning from Q1, Q2, Q3, and now this NFA is having epsilon, so we have to convert that to an equivalent DFA. Okay. So, now we will closely convert this. So, convert NFA with epsilon to DFA. So, that is the question here. Now, we will try to convert this. So, I will pick the color. Now, the first step here is we have to find the epsilon closure for Q1. So, epsilon closure for the initial state, and the initial state is called as Q1. So, when we do like this, we go for Q1, epsilon closure of Q1 is Q1, Q1 goes to Q2, and Q1 also goes to Q3 when epsilon is applied. Okay, now this state is called as A. We call this as A now. Okay, now what is the next step? The next step is we have to find the delta dash of this. So, delta dash of A comma A, because we have two inputs A and B, we will be applying delta dash of A comma A in the first state. So, we will make epsilon closure delta of, now in this case we take this Q A as Q1, Q2, Q3 comma A. Now, this A can be applied in Q1, Q2 and Q3. So, we will try to apply this. So, epsilon closure delta of Q1 comma A, delta of Q2 comma A, union of delta of Q3 comma A. Now, the only possibility A can be applied is, it cannot be applied in Q1, but it can be applied in Q2, it can be applied in Q3. When in Q2 when A is applied, it goes to Q3. In Q3 when A is applied, it goes to Q4. So, this is the only possibility. Now, here epsilon closure, and this will be resulting Q1 A, it results in pi, and Q2 it results in Q3, and Q3 when A is applied, it results in Q4. So, now we have to find the epsilon closure for Q3 and Q4. So, epsilon closure of Q3 union epsilon closure of Q4. So, now we are finding epsilon closure for Q3 and Q4. Q3 epsilon closure is Q3 itself. So, it results in Q3, and epsilon closure for Q4 is Q4 itself. So, it results in Q4. So, the answer here is we will name the state as state B. Now, we will find the delta dash. We will find the delta dash for input B also. Now, we will apply another input called as B. Okay. Now, here, so delta dash of A comma B. So, that is equivalent to epsilon closure of delta of Q1, Q2, Q3 comma B. Now, when B is applied, what is the possibility here? B can be only applied in Q2 alone. Rest of the states it cannot be applied. So, Q2 is the only possibility here. So, rest of the states will be resulting in pi. So, in Q2 when B is applied, it comes to Q2 itself. In Q1 you cannot apply B, and Q3 also you cannot apply B. So, what is the problem here? So, Q1 and Q3 will be resulting in pi. So, we will get epsilon closure of pi union Q2 union pi. So, now epsilon closure for Q2 is Q2 itself. Now, we will name the state as state number state C. Okay. So, we are getting the third state called as C now. Now, what we will try to do is we will apply both inputs on B now, and we will apply both inputs on C now. We will find out whether any new state is getting obtained here. Now I'll just make a bifurcation here. So in this case, now we'll try to apply delta dash of B comma E, that is equivalent to epsilon closure of delta of Q3 Q4 Q4 and A is applied here. So A can be applied in Q3. When A is applied on Q3, it goes to Q4, and in Q4 A cannot be applied. Okay, there is not any transition here. So the answer is epsilon closure. When A is applied in Q3, it goes to a state called as Q4. Q4 you cannot apply A, so I make it as pi. So epsilon closure for Q4 results in Q4 itself. Okay. Now you can see here that Q4 is a new state. Q4 is a new state. So we will name this as state number D. State number D. Okay. Now let us go for the next one. I will change the color here. So now we are getting another new state. Okay. Now delta dash of B comma B, which is equivalent to epsilon closure of delta of Q3 comma Q4 comma B. Okay. When B is applied, what is the only possibility? B cannot be either applied in Q3 or Q4. So the entire result will be pi. So epsilon closure for Q3 and Q4, B cannot be applied here, so it is pi. So epsilon closure is actually pi itself. Okay. Now since we are getting a pi, we will just make it as a trap state now. Okay. Now we will make this as trap state. So when you get pi, we will make it a trap state. Now we go for the next one. For B, we have applied both inputs called as A and B. Now for C, we have to apply. So delta dash of C comma A. Okay. Now epsilon closure of delta of C is actually Q2 comma A. Okay. In A, if we apply Q2, when we apply A, it goes to Q3. So we will get epsilon closure of Q3, epsilon closure for Q3, Q3 will be resulting in Q3 itself. Okay, Q3 will be resulting in Q3 itself. So the answer is Q3. Now we'll make this state as state number E. Okay. So now delta dash of C comma B, epsilon closure delta of Q2 comma B. So Q2 comma B will be resulting in Q2 itself. So epsilon closure for Q2. So we will get epsilon closure of Q2. So epsilon closure for Q2, we have already got this answer. Epsilon closure for Q2, we get C. So that is equivalent to C now. Okay. So now we have taken up to 5 different states, A, B, C, D, E. We have processed up to C states. Okay. Still D and E has to be processed. Now we will go for the next one. So I will add new page now. Okay. Now D and E. Now we have to process for D now. Now see what is the value of D now. So the value of D is, let's see here, D consists of only Q4. Okay. So we will just go here. Q4, there is not any transition now for A or B. So anyhow we have to process that also. So delta dash of D comma A, that is equivalent to epsilon closure of delta of D is actually Q4 Q4 comma A. Q4 comma A cannot be applied in Q4, so it results in pi. So epsilon closure for Q4 will be pi. So answer is pi itself. Now delta dash of D comma B is equal to epsilon closure of delta of Q4 comma B. So Q4 comma B, again you cannot apply B in Q4. So it again results in epsilon closure of pi. So this also results in pi. Now we have processed up to D states. Now we will process E state. Okay. So delta dash of E comma A. Now what is A here? E here. E is having a state. You just have check it out what E has. Okay. Now E has only one state called as Q3. Okay, only one state called as Q3. So we will try to do that. E has only one state called as Q3. So now we will go for this one. So delta dash of E is equivalent to epsilon closure of delta of Q3 comma A. Okay. E is, I will check it out. E is actually Q3. Okay. E is Q3 means it goes to Q4. Okay. Epsilon closure for Q4. Okay. Now see here. So when A is applied in Q3, it goes to Q4. So we will get an answer called as epsilon closure of Q4. So epsilon closure for Q4 is nothing but we already have an answer called as D. Okay. Now final answer, let us see delta dash of E comma B. Now epsilon closure of delta of Q3 comma B. Okay, B cannot be applied in Q3, so pi. So epsilon closure for pi is equal to pi itself. So we are not getting anything. Now what we do is we will just try to convert that into a transformation table, transition table. Now how many states are here? So we have 5 different states spanning from A to E. Now we will just convert this states now. So we have a table, we make a table now. So A, B, C, D and E. Okay. Now there should be another state called as trap state, because trap state is actually whenever we find anything which is pi, then we make a trap state. So T. Okay. Now since this is a DFA, now what are the inputs here? So A is an input and B is an input. Now see here, we will try to convert this into a table, then this table will be subsequently converted to a diagram. So there are 5 states and there is one more state that is called as a trap state. Okay. Now listen here, in this 5 states, which is called as a final state. Now we will go to the diagram. So in this 5 states, so initially the initial diagram consists of Q4. Q4 is called as a final state. Okay. Now which state can consist of Q4? Now B is consisting of Q4. Okay. And another state called as D is consisting of Q4. So rest of the states are non-final states. We will try to make it now. Now B and D are called as final states. So B and D are called as final states since it possesses a Q4 state. Now B is a final state. So I will make star here, it is called as final state, and D is a final state. Okay. So rest of the non-final states and initial state is obviously A. Now let us see that when delta dash of A comma A, where it goes. So delta dash of A comma A goes to B now, and delta dash of A comma B goes to C. So we will just make it as B and C. So here it goes to B and it goes to C. Now delta dash of B comma A and B comma B, we will check it out. So delta dash of B comma A goes to D and B comma B goes to pi. So pi means we will go for a trap state. Okay. So A goes to D and B goes to trap state now. So A goes to B comma A goes to B and B goes to pi now. So, pi instead of pi we may just make it as a trap state. Now, A comma B, C comma A. Now, we will check for this one, C comma A, where C comma A goes. So, C comma A goes to E and C, E and C. C comma A goes to E, C comma B goes to C. So, it goes to E and C now. So here it goes to E and it goes to C. Now, we will go for D now. So, D is in this line itself. So, we will just see here. So, delta of D comma A goes to pi and D comma B also goes to pi. So, D comma A goes to pi, B also goes to pi. Pi we cannot use it. So, instead of that we mention it as a trap state. It is called as a trap state. Now, the next one, E. When E comma A goes to D now, E comma B goes to pi. So, E comma A goes to D and E comma B goes to pi. So, we will make it as a trap state there. And trap state, if A is applied, it goes to trap state. If B is applied, it goes to trap state. Now, this is called as a DFA diagram. Now, we will just try to convert this into an equivalent diagram. So, how many states are here? So, we have 6 states here. Okay. So, we will try to convert this into a diagram now. Okay. So, we have state Q1, sorry, should not be Q1, it should be ABC, isn't it? So, we will try to make it out, this called as, so A state, so we will make it as ABC, okay. So let us make this as state A and this is an initial state. Now, B is a final state. We make C is a non-final state, okay. Again, D is a final state, okay. We will make E here, E is a non-final state and we have a trap state now, okay. Now, when in A is applied, it goes to B, so it goes to B. When B is applied, it goes to C, so we just make it here, it goes to C. In B, A is applied, it goes to B itself, so I make a self loop here, A. In B, when B is applied, it goes to a trap state, so just go to a trap state, okay. And now, in C, when A is applied, it goes to E, okay, E is here. When A is applied, it goes to E. In C, when B is applied, it goes to C itself. When B is applied, it goes to C itself. Now, in D, when we apply 0, A, it goes to D. Okay, now for D, we will just check it out. D, either it is 0 or 1, it goes to trap state, isn't it? So, 0 or 1, it goes to trap state, or A or B, it goes to trap state now. Now, in E, when A is applied, it goes to D. In E, when A is applied, it goes to D. In E, when B is applied, it goes to trap state. It goes to trap state. Okay. And only one final thing is required, that is trap state alone. So, whether it is A or B, we go to trap state itself. Okay. Now, this is called as a DFA diagram for the given NFA. Okay. So, that's about the concept here. So, thanks for watching the video. Have a good day.